Here's a piece of code that demonstrates a sort of dirty trick. And code tracing examples that do this are a little bit cruel. We have to understand this because there are lots of cases in real code where this does happen for very good reasons. And the trick is that we have a variable in main called z, and up here in f, there's also a variable called z. And so maybe you've guessed it, it's going to be a scoping problem. It's weird to write a program where all the variables are have names that are one letter long, and also that in every function there's a variable called z. But it's quite reasonable if you're writing a large actual program, if you have tons of functions, there will be a lot of cases where the same name is used in different places. And it's important to understand that because of the rules of scope, the z that exists inside of here is completely distinct from the z that exists in main. The variables inside of each function are the personal belongings of that function. And it's perfectly fine for you and I to both have the same belongings. If I reach into my pocket, I'll pull out a wallet. If you reach into your pocket, you might pull out a wallet too. But obviously, you wouldn't expect to reach into your wallet and pull out my credit card. It's fine for there to be an object with the same name in two different contexts. So let's trace through this. This is one of those examples where if you try to do it in your head, it's really easy to get messed up because of the name z meaning different things in different parts of the program. In particular, you will notice that the function f seems to modify the value of z. But that when we trace through it, we'll discover that this is not the thing that f is modifying. So if you try and do this in your head, you might make the mistake of thinking that as of this line here, the variable z in main is not equal to 10. But we'll see that it actually is. And that's just because the typical rule that'll become very important to us in October is that the only time ever that a variable can be modified is if you put it on the left-hand side of an equals sign. And just because I give f the value of my variable doesn't mean f has the right to change my variable. F can change its own variables, f can have the value that I gave it, but f doesn't have the right to see any of my personal possessions if I'm main and I happen to call f. We will see a way in October to give another function access to modify our own possessions itself, but unless we explicitly do that, then other functions don't have the ability to break into main and modify the variables that are declared in main. So let's trace this. So you might have noticed since the last video I recorded, I've added some nice handy line numbers over here. So we start on line number 8, and we proceed as usual. We draw ourselves a nice scoping box for main. And I'll just sort of ran off the side of the page there. Okay, there it is. And main has two variables, and they are called x and z. And we can see on lines 8 and 9, x and z get the values -999 and 10. And I really encourage you to try tracing through this example yourself. You might even want to try tracing it now before you've seen what I do. But certainly after you've watched this video, give it a few hours and then try going through the example again. It's crucial that we understand the distinction between different scopes. Okay, line number 10, x equals f of z. Okay, so we know the rules for assignment statements. We just ignore this part, and then we try and work out the right-hand side. So the first thing we do, I'm currently inside this scope. I sub in the value of z, so that's 10. I can't stress enough how important this is. We do not want to get the impression that f is being given z. F is not being given z. F is being given a number. It's being given a sheet of paper with the number 10 on it. F has no idea where that originally came from. So I call f with the argument 10. And we know how to set up our function after we call it. We first draw a nice scoping box for it out here, outside of the scope of main. And then we create a box on the diagram for every one of the arguments of f. And f only has one argument. It happens to also be called z. But that actually isn't the source of much confusion. F doesn't know anything about main's personal possessions, and main doesn't know anything about F's personal possessions. Main is just calling F and giving it the number 10. So F has this variable called Z, and the argument gets passed in and provided as the value Z, so Z now has the value of 10. But this is sort of what we expected so far. We expected that the variable Z and F would have the value 10. The issue that we're going to see in a minute is that we need to understand that F's variable called z is different from the one in main. So we're now ready to finish the call, and we start executing the code inside of f. So line number 2, z equals z plus 1. So currently, once you start executing in f, you are now in this scope. And remember that the rules for scopes say that when you go looking for a variable, you first look inside the scope you're in, and if you can't find it, you're allowed to exit the scope and look outside. But just to be clear, it won't come up in this example, under no circumstances are you allowed to go back into some other box. So if I can't find the variable here, I go looking out here. If I can't find the variable out here, I am absolutely not allowed to go inside and look in this box here. I'm only ever allowed to leave the scope. I'm never allowed to enter it. I may search for a variable. So line 2, z equals z plus 1. Well, z in this scope is this, so it's 10. So z equals 10 plus 1, which is 11. Okay, so we take the value 11 and we assign that to z. There it is. Let's just clean that up a bit. And then we print a line of output. End of f. Okay. End of f. Z is, and then we get the value of z, which is 11. Okay, return z times 2. So we make a note, what is z times 2? Well, z is this, so z times 2 is 22. And we're going to return 22. So I go back to where I called the function, that's down here, and I sub in 22 in place of that function call. And then I absolutely, as we know, I absolutely destroy that scope. Let's see if I can circle it. There we go. It's gone. Oh, it's not entirely gone. We destroy this little bit too. It is absolutely now gone. We don't leave any trace because if we do, we might get confused. Okay, so now I'm back in main, x equals 22, and notice that any confusion about z is now resolved. There is no second z on my diagram anymore, so x now equals the value 22. All right, and then we print two things. We print end of main twice, and the first time it's end of main, x is, we go looking, x is the value 22. And then the third line here is end of main. Z is, and we go look at the value of z, it is 10. And because we, at least in my mind, because I use that diagram, I was never at risk of confusing this z with this one. But it's an easy mistake to make if we don't keep our thoughts organized. So the next few tracing examples will not only show how we get around this problem, but what happens if even stranger things happen, especially what if we have scopes inside of main, like a while loop or an if statement, and we call functions inside of those.